do a new topic. It's actually one of my favorite topics, nuclear chemistry. I wish I could spend more than a couple days on it, but that's all the time we have to spend on it. It's interesting, it's easy, I like doing it. So this word here, nuclear, what do you guys think of when you hear that word nuclear? Hayden, what do you think of when you hear that word nuclear?
Bombs.
Bombs, okay, I agree. Lots of energy, lots of bombs, but this word though?
Nucleus.
Nucleus, exactly right. And here's the thing, nuclear chemistry, stuff happens to our nucleus. Okay? A nuclear reaction means my nucleus changes. And the reason why we think of bombs, we think of lots of explosions and energies, there's a lot of energy keeping the nucleus together. So if you change the nucleus, it releases a lot of energy. So we're gonna get that down. Okay. What particles are in the nucleus again? Say that, Kayla. And what else, Mary? Not that. Protons and neutrons. Exactly right. And here's the thing. What happened when we change the number of protons? When we change the number of protons, we
change the element.
Change the element completely. So here's the thing. When I have a nuclear reaction, I change my element when I change the number of protons. For like hundreds of years, those of you taking the AP World History test, alchemists were trying to make other things into gold. They were trying to change elements. Cannot be done with a chemical reaction. But nature makes new elements all the time. Maybe not gold, unfortunately, but they make new elements all the time just naturally. Okay, we're going to start with, before I show you a quick video, I'm going to show you this, talk about this term radioisotope. And what a radioisotope is, it's an isotope of an element that has an unstable nucleus and it undergoes a nuclear reaction. And here's the thing, what happens when you have a nuclear reaction, stuff gets emitted, okay? And that's the stuff that it's like, oh, it's so dangerous, okay? Particles and or wave, we could say energy waves, are emitted, and the blanket term for those things is called radiation. And today we're going to learn about 3 kinds of radiation. Write on these notes here: alpha radiation, beta radiation, and gamma radiation. Those are the 3 types of radiation we're going to learn about. They each have their own particular waves or particles that get emitted. And one last thing I want to say about this, these reactions, these nuclear reactions, cannot be sped up, slowed down, or even stopped. and I'm not asking you guys to memorize this, but there are certain factors what makes something a radioisotope. First of all, bigger elements at the periodic table. You don't have to write this, but bigger isotopes with lots of protons and neutrons. Lots of protons and neutrons tend to make the nucleus unstable. And another key factor, nuclei like to have the same number of protons and neutrons typically. So another thing, have different protons in like the first 20 elements of the periodic table. Most of them do have, all those isotopes pretty much have the same numbers of protons and neutrons. Once you get down lower in the periodic table, there's always a lot more neutrons than protons. And that tends to make the nucleus more unstable. Alright, so I'm going to show this video. It takes 2 minutes. Look at the 3 different types of radiation that they show here, and we're going to talk about them. It's kind of a cute little cartoon type thing.
The nucleus. The nucleus of every atom is made up from protons and neutrons, about the same number of each. The nuclei of most atoms stay like this forever, but radioactive nuclei are unstable. They're like pieces of popcorn waiting to pop. Once in its life, a radioactive nucleus decays and throws out part of itself as radiation.
And it spits out particles.
Some atoms throw out a pair of protons and a pair of neutrons together as a particle. This is alpha radiation. In another nucleus, a neutron might suddenly change into a proton, throwing out an electron at the same time. This is beta radiation. Gamma radiation is an electromagnetic wave with very high energy. It's sometimes given off by a nucleus which has just decayed in another way, as the nucleus struggles to make itself stable. Atoms of the same type always decay in the same way, so it's often possible to work out what type of atom is involved by detecting and measuring radiation. The radiation is a telltale clue to the atom which created it.
Okay, so before we get into the 3 types, I forgot, I need to give you a definition. Radioactivity, it's the process whereby substances give off radiation, but English teacher would not like having radiation in the definition because it's part of the root. So we could say it gives off rave and energy particles. And they've known about substances being radioactive before they even knew about the nucleus and how it looked and what it was actually composed of. They couldn't really explain why way back in the day, but they did know about things giving off radiation. Alright, so there are 3 kinds. There's alpha radiation. In the video she called it beta radiation. Here we're going to beta radiation. And then gamma radiation. Cool. Alright, so the first thing, alpha radiation. Alpha radiation is when 2 protons and 2 neutrons are emitted in a nuclear reaction. And this particle with 2 protons and 2 neutrons is called an alpha particle. I'll give you a second to catch up. There's a couple different symbols for this. First symbol is just a Greek letter for alpha. Okay. It looks like an infinity sign that hasn't quite been finished. Okay. That's a symbol for an alpha particle or alpha radiation, but that's not the one we're going to use when we do our nuclear equations. Nuclear equations are fun, they're easy to do. It's the second easiest thing I teach you all year. The symbol that I want you to memorize, to me that's so important. 2 protons. What element do I have when I have 2 protons? Helium. So they do the symbol He, and then for these equations you need an atomic number down at the bottom, and you need the mass number at the top. So it has been a while. This right there, there's not a lot of memorizing today or tomorrow. If I want you to memorize, this is something I think you should memorize, this symbol and beta particle symbol. But just a quick reminder, that 4, that's called a mass number. And what was the mass number consisting of? Who remembers? Go ahead, Maddie.
The combined the protons and the neutrons?
Yep, you add them together, protons plus neutrons, correct? And then that right there, the atomic number is the number of what? Thank you. Say it again, please. Protons, number of protons. I am. Okay. All right. So these are going to be very important: mass numbers and atomic numbers.
Nosy, nosy.
Exactly. Let's do an example of what happens here. Okay. So, what's the first element you guys usually think of when you think of nuclear radiation and all that stuff?
Uranium.
Yeah, that's what I figured you'd say. Uranium. There is an isotope of uranium that's pretty stable, but uranium with a mass number of 238 is not stable. Okay. Now, what atomic number do I have to put there, please? For those of you at home, you're looking at the periodic table. 92. 92. Okay, so if this undergoes alpha decay, first thing you're going to do, put that symbol that we did there for the alpha particle. Write that down. Have your 4, your 2, and your helium. Okay? Plus. Plus what? I'm glad you asked. Let's talk real quick. I need to leave a little space and to the side. Key point here. These mass numbers and atomic numbers must balance in nuclear equations. What that means is my mass number on the left, 238, better add up to the mass numbers on the right. Okay? So what's my mass number going to be for my new particle here, my new element, I should say. 234. Oops, 234. 234 plus 4 is 238. I just balanced my mass numbers. Now how about my new atomic number? What number is that going to be to balance it out? 90. Okay. And so finally, look at your periodic table. What symbol, what element do I have now? Not thallium, actually. Thorium. Thorium. Exactly right. These atomic numbers and mass numbers have to balance out, and by the time you do 2 or 3 of these nuclear equations, you're going to be like, that's the second easiest thing you taught me all year.
How did you get that again? Can you just repeat it?
Sure. This right here, if it's alpha decay, put the alpha particle down. Then 4 is the mass number here. The mass number that I put in my new element has to total up to 238. So you know it's 234. Okay. 2 is the atomic number. So the atomic number I put here has to add up to 92 on the left.
Oh, okay.
And this right here is the key number that tells you what your symbol is. And I'll expect you guys to be able to balance the mass numbers and give me the new mass number, balance the atomic numbers for that, and then look at your atomic number for the new symbol. Okay. So after a couple more, you're going to see it's pretty simple. Right. So that's alpha radiation. Do me a favor, that right there, that symbol, that's what I need you to get up in your brains. Now the next thing, beta radiation, something different is emitted this time, not 2 protons and 2 neutrons. What is emitted? An electron is emitted. But here's the thing, it wasn't one of the electrons that was there orbiting this particular isotope. It is emitted when, I don't know if you caught this, it's pretty cool if you think about it. A neutron breaks apart and forms a proton and electron. So here's the thing, the proton stays there, and that gives us a new element, and the electron is what is emitted. Okay, the electron is what's emitted. And so a beta particle, well actually, before we do the beta particle, let me show you an example of a neutron breaking apart. Okay, so I'm going to make this a lowercase n for neutron. Okay. It's not a proton, so you give it an atomic number of 0. Okay, write that down. It is a neutron, so you do give it a mass number of 1. Okay, that's the symbol for a neutron if you ever need to use it in nuclear equations. So if it breaks apart, it forms a proton. So your atomic number is 1. And what's the element with 1 proton? Hydrogen. That's the symbol they give the proton. This is a neutron. This right there is the proton. And it has a mass number of 1 because 1 plus 0 is 1. Right? And then also formed here when this does, we set an electron. What symbol is electron? E. Sometimes they put the minus there, sometimes they don't. So you could see the E with a minus. It does have that negative charge, but sometimes you won't see it. Now here's the thing, okay? Its mass number is 0 because it's not a proton or a neutron. And look, it balances. 1 mass number on the left, 1 mass number on the right, okay? And so the atomic number down here makes it balanced. 1 minus 1 is 0. This right here That is your symbol for beta particle. And sometimes they do the Greek letter beta. It's a B, but you put a stick at the bottom of it, like that. This right here, that's what I need you to memorize. That's the particle that's emitted. Proton stays there in the nucleus. Example. Carbon-14 is radioactive. It'll go through beta decay. So what I need you guys to do, start by writing down that symbol for beta particle. Plus, what's our new thing? What new substance happened there? So start with the mass number. What mass number is this substance going to have? 14. That's how it's going to balance out. 14 plus 0 equals 14 on the left. All right. How about my atomic number?
I don't get how
You did. 7 minus 1 is 6. Alright, does that make sense? 7 minus 1 is 6. That's how it's going to balance. So Josh, what's my new element? Nitrogen. Okay. That's what happens. So what's your question? You do too. What was your question?
no.
Okay. Alright. So what happens is one of these neutrons, part of that 14 right there, okay, it breaks apart, okay, it forms a proton that stays there. So my mass number didn't change. I might have lost a neutron, but I gained a proton. And the electron that's also formed in the process, that's what's emitted. Only the electron is emitted. They call that the beta particle. Okay. They don't call it an electron because it wasn't one of the electrons floating outside in the shell. Okay. This is just a symbol for a beta particle. You good? You look like you wanted to ask a question.
No, I get it.
Okay. All right. So that's beta radiation. Last one here. How much time do I have? Enough time? Yeah, I do. Good. All right. Gamma radiation. Gamma radiation, not a particle. Okay. This is not a particle giving off. These are. It's the emission of high energy electromagnetic radiation waves called gamma rays. We love gamma rays. Incredible Hulks. Okay. All right. Symbol for it. It looks like a Y with a little tail, like that. Okay. And since it's not a particle, no protons, no electrons, no neutrons, none of that, this is all it is. You'll see one of these funny Y's for a gamma ray. Okay. Bullet point here. Oftentimes, this is emitted with alpha or beta particles. Two radiations at the same time. Sweetness. Sweetness. Alright, so we're going to finish up today with our last example. It's a Y and I put a little squiggly on the bottom of it. Yeah. Okay. Alright, so thorium with the mass number of 230 is something that doesn't have a stable nucleus. Okay. It's going to go through a nuclear reaction, and this time I'm not going to tell you what type, you're going to tell me. What I am going to tell you is it forms radon-226. Okay? It also emits gamma ray. And I want you to tell me here what kind of particle we have here. And when you're trying to figure the particle, it's the same type of thing. You got to make sure the mass numbers balance and then your atomic numbers balance. So what's my mass number, first of all, for this particular example? 4. 4 plus 226 is 230. All right. What's my atomic number for this example? 2. 2 plus 88 is 90. What symbol do I put there? He, helium. And what kind of particle is this? Alpha radiation. Good. So sometime I may ask you to figure what this is. Sometimes I may give you this and ask you to figure out what the new element is. You have